Okay, I'm not sure exactly where we left off, but I want to address the p-value a better way to show you how to do that to get a precise answer. So to do that with your technology with StatCrunch, go to calculators and go to T. And your degrees of freedom for this problem was 9, I believe. 2, 4, 6, 8. Yes. So our degrees of freedom is 9. And then if you will put in, this is a right tail test. Let's see. Yes, this is a right tail test. So if you will do greater than or equal to and do your test statistic value 3.63, you will get the p-value here. So this would be 0.003. So looking at question number 5, this is similar, except this is a two-tail test, and you can go in and calculate the critical value if you want to. Or let's open a StatCrunch, and we know our degrees of freedom is alpha is 0.01. Divide that by 2, so alpha is 0.005. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 15 values here for making sure I'm on the same problem as y'all are. Yeah, I think it's 15 values. Let's just try it and see. If you will go to calculators and T, and then it's a two-tail test because there's an equal sign. Degrees of freedom would be 14 and 0.005. So our critical values are going to be negative 2.977 and positive 2.977. Now, to determine the test statistic, you will go to T-Stats, one sample with data, and you can go ahead and put the hypothesis. Let's see. So your test statistic is negative 2.28. So let's talk about the p-value, and then we'll go back and do the other part. So go back to Stat, Calculators, T, and put in your test statistic, and this is a less than or equal to negative. So you get 0.01936. Now that's just one side. The other side, you would double this number because it's a two-tail test, and that's how you get 0.039. Now, as far as rejecting or not rejecting, let's go over a two-tail test and see. We know our critical value was, I can't remember. I always do this, and I didn't write it down. Negative 2.977. So negative 2.977 and positive 2.977. So the area of rejection is less than negative and greater than positive. Our test statistic is negative 2.28, which would not be in the rejection area. So we will not reject the null. It didn't provide us enough evidence to conclude that it's going to be different from 10. Right, based on what we see, the mean is 10 because we cannot reject it. Moving on to question number 6. Here we are given n, we're given everything, and of course I messed up here and put the wrong hypothesis, but basically, does the sample provide evidence to conclude that average utility in the state was lower in the winter of 2009 and 2010 than it was in the winter, found a mistake, of 2008 and 2009. Well, 2008 and 2009 so we want to know if is there evidence to conclude that the bill was actually lower. So our hypothesis, or null, is that it's greater than or equal to, and then our alternate, what we want to know is if it was lower. So our alternate would be lower than 186, what we're trying to test here. Okay, so that's why you have to set it up that way. Now all of this you can do just like we've been doing, and then you're gonna change the value here and see if it changes or not. Use your test you've been using to do this. We can work this real quick in StatCrunch just to see the critical value. Let's not look all that up. Let's just go straight to whether we need to reject or not. So with your test here, your critical value is negative 1.677, and then your value here would be negative 2.96, so we would reject. And then because it's in the rejection area, reject. There's sufficient evidence to conclude that the average bill was lower in 2009-2010 than it was in 2008-2009. Be careful with the wording on those. It can trick you, but just keep it straight in your mind what the null is and what the alternate is. But then it asks this question: if we change alpha from 0.05 to 0.01, would our answer change? And you would work it the same way and draw it and see if it's still in the rejection area. If it's still in the rejection area, which it is, you would know that it didn't change. You're still rejecting it. So you do that test again to see if you would reject it or not. And you will reject it. Question number 7, I'm trying to kind of just go through this quickly because you basically work all these the same way. Same thing here. Now on this one, we're saying the average size was 2271. Okay, that was our average. So that's why our null is the average is 2271. But then it says use alpha. Does this sample provide enough evidence to conclude that the average size has changed? So either it's equal to the average or it's not equal. If it's not equal to the average, then that proves it has changed. So that's why it's a two-tailed test. And here's your critical values, and here's your test statistic. And you will see that the test statistic is not going to be to the left of your left tail, so it's not in the rejection area, so you do not reject it. The data did not provide sufficient evidence to conclude that it has changed, so therefore the null, that it's still the same, we're not rejecting it. If we rejected this, then we were saying, hey, it has changed. But since we're not rejecting the null, there's not enough evidence to show that it has changed. That was the test. So here, according to research, holiday shoppers spend an average of $362 over the weekend. It says retailers were concerned that the recent economic downturn was going to affect the holidays. So they're saying, hey, we think that they're going to spend less. Well, first of all, we're going to, or our null is going to be, hey, they're spending at least this amount or more. And then our alternate would be, we're trying to test to see if they actually spent less because of the economy. So if we end up rejecting the null, that means we're accepting this, that they're spending less. If we end up not rejecting the null, that means, hey, based on what we see, the average still is around 362 or more. They're not spending less. So when we do this, our critical value is negative 1.341, and our test statistic is in that left tail, that rejection area. So we're going to reject the null, which means that, hey, they did spend less than average. And then you remember how I showed you the p-value. Okay, question number 9. Same stuff over and over again. Here we want to test that it's not changed. The average hasn't changed. When it says that, it's equal to the average or not equal to the average. That's how you prove if it changed or not. So it looks like we didn't reject the null. What that means is it hasn't changed. Now it says that what conclusion, let me scroll down. What assumptions need to be made to perform this analysis? Remember, if the sample size is less than 30, we're assuming the population follows a normal distribution. Okay, question number 10, same thing, same type of problem. Notice that the null always has the equal to in it, okay? It either has the equal sign, less than or equal to, or greater than or equal to. The null always has that in it. And question number 11, some of the same stuff. So you should not have any trouble using technology to perform these. So that concludes section 9.3.